Hello again, Dr. Mashburn. And so we're going to end our muscle lecture doing our systems connections. And as you'll remember, each unit we like to go back and think about how the unit we just learned relates to the units we've previously learned, and to think forward about how it's going to interact with future units that you're going to learn. And so I've made this PowerPoint for you to just kind of remind you of your different organ systems and how your muscles and organ systems interact with each other. Now this is a brief list, and you surely can go back to your own textbook, your own notes, and probably fill in even more information than I have done on this PowerPoint. And I encourage you to do that. I want you to think about these systems as many ways as you possibly can. So just because it's not on this list doesn't mean there's not a tie back. So make sure you take some time yourself and try to think outside the box and add some things to this list. You'll be doing this again when you get to the nervous system. So let's just go through our organ systems. Integumentary first. And if you'll remember, muscles, exercise increases circulation to the skin, so there's a tie-in. Your skin protects your muscles. Your skin helps to remove the heat generated by your muscles. You need your skin to make vitamin D, and vitamin D is needed for calcium, which you need for muscles. Your skeletal system. You can't move without your bones and skeletal system working together, right? Your bones store calcium that you need for muscle health. Your nervous system. Muscles don't move without nervous innervation. And the nervous system is also a way we express emotion, and so you smile and frown. That's using your nervous system and your muscles together. All right. Muscles need to be constantly innervated by nervous tissue, or they atrophy. So in order to maintain good muscle mass, you have to have the nervous system. You need your endocrine system. The endocrine system produces hormones, and hormones go in the blood. So we can say, well, muscles help return blood to the heart so that you can pump those hormones around your body. So we're just trying to think about how we can tie these things together. Okay? We also know that hormones influence muscle mass, so growth hormone, testosterone. The cardiovascular system. Well, you have cardiac muscle, right? You also have smooth muscle inside of your arteries, okay? You have skeletal muscle that plays a role in cardiovascular health. You need your skeletal muscle to help return venous return to your heart. You need your cardiovascular system to bring the oxygen and nutrients to the rest of your body, to the muscles. Lymph and immune, again, your muscles help return lymphatic fluid to your cardiovascular system. The immune system keeps your muscles healthy. I'm just doing these briefly. I guess you guys can read, so I'm just kind of briefly going through this. Respiratory, you need skeletal muscle, diaphragm. That helps you breathe, right? And as you exercise, use your muscles, you have to increase your respiration rate. The respiratory system gives us oxygen and removes carbon dioxide. The digestive system. Digestive system has smooth muscle to move food through it. As you exercise, as you exercise your muscles, you can shunt blood away from the digestive system and to the muscles. You need your digestive system to bring in nutrition for your muscles. So again, just kind of start brainstorming on how these units how these systems work together. Urinary system. As you exercise, that increases or helps promote good kidney health. You have a voluntary sphincter that allows you to decide when to urinate. Same thing with the digestive system. You have a voluntary sphincter to decide when to defecate. Okay. Reproductive system. You have muscles that you need for labor and delivery. Your reproductive organs, your gonads, make hormones that allow you to have muscle development. So again, I'm just kind of brainstorming here. You've got your textbook, got your notes. Just spend some time doing this. Now, we'll tell you, for the nervous system, you are not going to see this page, okay? I expect that you can do this on your own. So as you're learning the nervous system, you're going to be learning a lot of things about sympathetic and parasympathetic and central nervous system. So as you're learning nervous system, go ahead and start thinking about how you're tying that back to all your other organ systems, okay? Because again, I'm not going to do it for you in the nervous system. I'm going to let you guys figure it out, read your book, read your notes, and do it yourself, okay? But you can always email me if you have a specific question. Okay, so the last thing I want to talk about, because you guys are getting ready for your muscle test, and what I see a lot of times for this test is people wanting to take things in little chunks and just here and this, and so this is my neuron, and this is my axon terminal, and this is my neuromuscular junction, and this is contraction. And they have these little chunks of information, but they don't really tie them all together. And so I want you to think about muscle contraction as one long continuous cascade of events. And so the best way to do that is literally to take a piece of paper and just write it all out. And so I'm not going to do every step for you, but I'm going to give you a hint on how to go about thinking about this, okay? So literally take a piece of paper, and you're going to want to draw, your axon, okay, your axon terminal. You're going to want to draw your muscle, okay? And then we'll expand that muscle, okay, so that we have our transverse tubules and our sarcoplasmic reticulum, and then we're going to have our actin and our myosin. We'll draw our little thin and thick filaments. All right, so what I want you to think about is, okay, this is in the nervous system. In order for this neuron to have an electrical impulse, an action potential, the first thing I have to do is I have to set up my battery. So set up your battery, do your membrane potential. So draw you a cell and say, okay, more sodium in or outside the cell? More sodium in, more potassium, or outside the cell, more potassium inside the cell. There are more potassium channels, leak channels, than there are sodium channels. So more potassium goes out than sodium goes in. That makes the inside of the cell negative compared to the positive side of the outside. That sets up your battery, your resting membrane potential. All that's maintained by that sodium-potassium pump, okay? So now you get a stimulus. And so you have a stimulus to your neuron that causes the generation of an action potential. So an action potential travels down the axon. Well, make sure you remember what an action potential is. Go through your steps. Depolarization, repolarization, hyperpolarization, sodium leaving, potassium leaving. Make sure you know what kind of channels. Are these voltage gated? Are these ligand gated? Go back to your notes. You need to know voltage gated or ligand gated channels. Is sodium coming in? Is sodium going out? When the action potential reaches the axon terminal, there's another channel, voltage gated or ligand gated. There's a calcium channel, it's a voltage gated calcium channel that causes acetylcholine to be released into the synapse. That binds a receptor, which is a ligand gated channel, okay? So you've taken an electrical event, the action potential, turned it into a chemical event, the acetylcholine, back to an electrical event, because this ligand-gated channel is going to allow for the flow of sodium and potassium, generating another action potential, which is going to travel down the sarcolemma of the muscle fiber. Okay, I hope you're following me. Okay, but this is what you need to be able to do. So the action potential is going to travel down the sarcolemma. It's going to go down those T-tubules where you have voltage-sensitive voltage-sensitive channels. Calcium will be released out into the sarcoplasm. What happens when calcium gets out into the sarcoplasm? Calcium binds troponin, which causes tropomyosin to change shape, which exposes the myosin binding site on actin, right? Okay, so now you have your actin, and then remember you have your myosin. All right, so now you have your cross-bridge formation and your cycling. So you got to go, okay, somewhere ATP comes in, and at some point ATP is hydrolyzed to ADP plus PI. Know what happens. When do these two, when does this happen? When does ATP come in? What happens? The power stroke, the cocking of the head. Think about all those different steps, okay? As this power stroke is going along, then you're going to have your thin and thick filaments. They're going to start to get closer and closer together. That's going to shorten the sarcomere, and the muscle's going to contract. Now, after all that's happened, how do you relax the muscle? Well, you've got to stop that action potential. All right, so you block the action potential. So let's draw our neuron again. Here's our muscle. If you don't have any impulse coming from the nervous system, there's no action potential. There's no calcium entering into the axon terminal. There's no acetylcholine released. Any acetylcholine that was in the synapse is going to be taken care of by acetylcholinesterase. There's no acetylcholine. There's not going to be anything bound to those receptors. There'll be no more action potential traveling down the sarcolemma. It's not going to go down to T-tubule and release more calcium. Now the calcium can get pumped back into the sarcoplasmic reticulum, get it out of the way. using an ATP calcium pump. That's going to cause the troponin tropomyosin complex to change shape. Now your myosin binding site on actin is blocked and you can't form those cross bridges anymore, and the muscle will relax. So I did all that in about 90 seconds. All right, so just so I want you to be able to do that. If you can't write it out, at least say it, but I would encourage you to get a piece of paper and just start from the beginning of setting up your battery, generating your action potential, releasing your neurotransmitter across the synapse, binding the other side, generating another action potential all the way through cross bridge formation, and then again the steps of relaxation. Okay, if you can do that, that's a large part of the test, so make sure that you can do that, and it will help you as we move forward into the nervous system. Now that's not all of the test. You still got to know about energy for contraction, and isometrics and isotonics, and all the other things that we've covered. But again, what I see a lot of times is people just go, that stuff's too hard, I'm not going to learn it. And you'll pay for it on the test, because there is a lot of information about those particular things on your exam. All right, so that's the end of muscles. Good luck, go study, and I wish you well, and I'll see you in the next set of videos.